Oh, hey there! Funny finding you here as we dive into factorials. The reason why I want to review what factorials are is just in case you haven't had a real good basis on this, maybe in pre-calculus or other previous math courses, you should understand what the factorial operation is. It's going to be coming up a lot in this chapter and later chapters. So very, very cool operation that you never thought would be so important. And you'll see how important it is, and it's not that bad. So what is a factorial? A factorial is a different kind of operation where we essentially take a number and we put an exclamation mark right next to it. So it doesn't mean 5, right? It's not an exclamatory thing, but it is something very cool. What it says is we take that number and multiply it by 1 less every time until we get down to 1. So for instance, 5 factorial would be equal to 5 times 1 less than 5 is 4. 1 less than 4 is 3, times 1 less than 3 is 2, times 1 less than 2 is 1. And we always stop at 1, and we always go down by 1 every time and take the product of all of that. So when you take the product of all of this together, that ends up equaling 120. So 5 factorial is 120, or 5 is 120. All right, joking aside, n factorial in general would be you have some number, you start out with that n, and then you multiply by n minus 1, 1 less than n, and then by n minus 2, and then by n minus 3, and so on and so forth until you get all the way down eventually to 2 times 1 and stop. And you know that we're going to eventually get down to that 1 because that's where all factorials end. It's very cool, always going down by 1. So that's your general idea of what a factorial is. So let's do a couple of simplifications now. This will help train you for some stuff coming up in the not too distant future. So we're asked to simplify each expression. So 12 factorial over 10 factorial is a couple ways we could look at this. Let me do it first by expanding it all out. That'd be 12 times 11 times 10 times 9 times 8 times 7 times ... all the way down to 3 times 2 times 1. That's what 12 factorial is, all divided by 10 factorial, which would be 10 times 9 times 8 times 7 times ... times 3 times 2 times 1. So what you will notice in here is we have 10 times everything that comes before it going down by 1s and 10 here. So all of that divides out. And you're just left with 12 times 11, which is equal to 132. It's very sweet. Now other people will look at it this way. They'll say, okay, I've got 12 factorial is the same as 12 times 11 times 10 factorial. 10 times 9 times 8 times 7, all over 10 factorial. This is a quicker way to write it. And the same number divided by the same number, provided they're not both 0, divides out to 1. And we get 12 times 11, which is 132. You could look at it either way. I'm just preparing you for a couple different ways of seeing it. All right, in this problem here, we've got a little bit of algebraic expressions going on. You got this. We're going to handle it together. N plus 5 factorial, that is not so bad. We're going to expand it out a little bit. That's n plus 5 times n plus 4. 1 less from 5 is n plus 4 times n plus 3, and so on and so forth until we get down to 2 times 1. All over n plus 4 factorial. So that would be n plus 4 times n plus 3 times n plus 2, and so on and so forth until we get down to 2 times 1, and then we're done. Now what you'll notice is we have n plus 4 times all those other numbers up in the numerator. Same with all of that in the denominator. It all divides out. N plus 4's divide out, n plus 3's divide out, n plus 2's divide out, like the 10s, the 9, the 8, the 7 in that last problem. So what we're left with is just n plus 5. Or, again, I'll show you how we could have looked at that. You look at that as n plus 5 times n plus 4 factorial. We realize that we have n plus 4, n plus 3, n plus, and we just write it in condensed form, all over n plus 4 factorial, and these will divide out. They're the same number, and so we are left with n plus 5. So it depends on how you want to look at it. Both ways are good. I'll show you how to understand it. The last, but certainly not the least, 4n minus 2 factorial over 4n factorial. Okay, so this one is 4n minus 2 times 4n, we're going to go 1 less, minus 3. You subtract 1 would be 4n minus 4, and so on and so forth until we get to 2 times 1, and then we're done expanding it. Who knows how many terms we'd have there. This would be 4n times 4n minus 1 times 4n minus 2. There we go. times dot, 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 times 2 times 1. So what's going to happen is you're going to end up with the 4n minus 2s. They'll divide out. Then there would be a 4n minus 3 and a 4n minus 4, and then the 2 and the 1s. Everything divides out except for what's here. So the numerator all went to 1 because we divided it all out. The denominator was 4n times 4n minus 1, which simplifies to 1 over expands 1 over 16n squared minus 4n, just distributing here. Or we could have recognized that we had 4n minus 2 factorial up in the numerator. However, the 4n times 4n minus 1 times 4n minus 2 factorial. And if you write it like that, that's fine too. These will divide out. How about that? And you're left with, well, our answer from before, 1 over 4n times 4n minus 1. So there you have it. A brief review or maybe a brand new lesson on factorials and how to expand them and then divide them out, or how to just simplify them pretty quickly. That will help you in the not too distant future. I will see you in that not too distant future very shortly. Peace.